I'm just going to go through all of these. I'm going to explain how exactly to identify what type of reaction they are, and I'm going to also explain how to determine the products. Okay, so what you should actually have out right now in front of you, if you go onto the class website, just pause this video really quickly. If you go onto the class website and go under student files, you should find the cheat sheet, which has all of the different types of reactions which you find on your green sheet, which you will have for the retake and you will have for your final exam. All right, because I'm going to be referencing that. I have that in front of me, so you need to have that in front of you. Okay. All right, so let's look at the first one really quickly. You have BaClO3, 2. And you have one thing, and if you notice, there are two blanks right after it. So what you know is happening is it's being broken apart into two different things. You can't write two things in one blank. There's only one thing in each blank. So you know it's being broken up into two separate things. All right, so therefore, first of all, automatically, we know that the type of reaction that is occurring is decomposition. That should be something that's obvious because you're taking one thing and breaking it apart into two. So it's going to be decomposition. But here's the issue. What type of decomposition is it? Okay, so if you look at your cheat sheet, you'll notice it is a 2E because you have a metal and you have ClO3 right behind it. Okay, so if you notice for 2E, your two products are going to be a metal chloride, MCl, and O2. So the easiest product is O2, so I'm just going to write O2 right here. Here's O2. And your other product is a metal chloride. Now, my metal in this case is Ba, so I'm just going to write Ba, 2+, and I need to cross it with Cl-. That has a -1 charge. So I'm not even going to show my crossing because I'm hoping at this point you guys can totally do that. But here, I'll just do it one more time for good measure. Okay, so my other product is BaCl2. Okay. Now, I'm 2/3 of the way done. I've determined what type of reaction it is. I've written my products. Now the only thing that's left to do is balance. Okay, I've got one Ba here, one Ba here. I've got one Cl here. I've got two Cls here. My bad. Two Cls here because that 2 refers to the Cl. But I've got 6 O's here because it's 3 times 2. So I need to put a 3 in front of this O2 to make it 6. And now I am done. All right? Let's try the next one. I have C6H12. As soon as you see anything that just has carbon and hydrogen, that's a hydrocarbon, you should automatically be thinking combustion. If you're not automatically thinking combustion, look at the products. You only have water and CO2. That's combustion. Okay, so if you look at your cheat sheet, it says a hydrocarbon plus oxygen. Well, I can't just write oxygen as the other reactant because oxygen is diatomic. So I need to write O2. Okay, and this is combustion, by the way. Okay, now I need to balance. So I have, remember, for combustion, it's your C's, then your H's, and then your O's that you need to balance. So I've got C6 here, so I need to put a 6 in front of here. Okay, I've got 12 H's here, so I need to put a 6 in front of here. So now I've got 6 O's plus 12 O's. That gives me 18 O's. I've got a 2 here, so in order to make that 18 on this side, I need to put a 9. Now, if you need to add up on this side to get that 18, that's perfectly fine. Okay? All right, we're going to just chug along. Now, in this reaction, if you notice, I've got one element. Yeah, there's a 2 there, but remember, if you don't have more than 2 different elements bound together, that's considered to be just an element. It's not a compound. So you've got an element plus a compound. As soon as you see just an element plus a compound, you automatically should be thinking single replacement. And with single replacement, remember, positives kick out positives and negatives kick out negatives. Okay, so Cl, since it's naturally negatively charged, it's going to go in there and kick out Br. Normally, guys, you would have to check the activity series for single replacement. However, on a quiz like this, I'm not going to give you a problem that doesn't occur. All right, so you don't actually, for these, have to check whether Cl is higher on the activity series than Br. But normally for single replacement, you would have to do that. So Li is going to bind with Cl, so it would be Li plus 1 and Cl minus 1. Okay? Cross your charges and you get LiCl. And the other thing that happens is that Br is going to be kicked out. So Br is all by itself, but remember, since Br is diatomic, it can't stay by itself, so it would be Br2. Okay? Last thing we have to do, we have to balance. I've got 2 Cls here, 1 Cl here. I've got to put a 2 in front here. Now I've got 2 Lis. Now I've got to put a 2 in front of here. And now I'm done. Okay? In this reaction, we're moving along, chugging along. If you need to pause me, rewind me, please do. All right? Here I've got 2 elements by themselves, and then they combine into one thing. Automatically, when I say that, when they're 2 things are combining into one thing, you should be thinking synthesis. Okay? Now I need to take K and P and combine them, which means I need to cross their charges. The charge of K is plus 1. The charge of P, I believe, is minus 3. So when I cross their charges, this becomes K3P. Last thing that I need to do for this problem, I need to balance. I have 3 Ks here, so I need to put a 3 in front of here. I've got 1P, I'm good to go. Now, number 5, I've got a hydrocarbon plus oxygen. Automatically in your head, you should be thinking combustion. All right? Products of combustion. Look at your cheat sheet. Okay? Your products of combustion are going to be carbon dioxide, CO2, carbon di, 2 oxygens, plus water. Now at this point, what you need to do, the last thing you need to do in any of these reactions is balance. I've got 3 C's here, so I need to put a 3 in front of here. I've got 8 H's, so I need to put a 4 in front of here. Now let's count up my O's. Remember, C, then H's, then O's. I've got 6 O's plus 4 O's, that's 10 total. So I need to put a 5 here. All right? Now, for number 6, if you notice what's happening, Na is here, it's added to something, and what happens is that a brand new compound's created, and Mg is all by itself. So if you can imagine, Mg used to be bound to SO4, and it was kicked out quite rudely by Na. So if anything's being kicked out in a reaction, that's automatically going to be single replacement. Okay? So Mg used to be bound to SO4, so let's find out what that looks like. Mg has a 2+ charge. If you forget the charge of SO4, which is one of your polyatomic ions, if you notice, guys, I give you the charge right here. If you uncross your charges, make that subscript 2, the charge of SO4, make the unexistent 1 of SO4, the charge of Na, those are your charges. So 1 for Na, 2 for SO4. So here's a 2+ for Mg, and SO4 has a -2 charge. Okay. When I cross my charges, these 2's cancel out, so I end up with just MgSO4. Last thing I need to do, I need to balance. I've got 1 Na here, 2 Nas here, so I need to put a 2 in front here. 1 Mg, 1 Mg, 1 SO4, 1 SO4. I'm done. As easy as that. Okay, let's go on to the next one. If you guys need to pause, it's totally fine. Okay, here I've got Ag plus something. I have no idea. It gives me 1 compound. So if you think about it, Ag plus something gives me 1 compound. Well, that's going to be synthesis because I'm taking 2 separate things, combining it into one thing. So it was Ag plus, well, my other element that I'm combining is oxygen. But it can't just be oxygen like that because oxygen's diatomic. So it's going to be O2. Last step I need to do, I need to balance. I've got 1 Ag here, 2 Ags here. So I'm thinking that's not quite right, but look at this. I've got 1 O here, 2 O's here. So I'm going to need to put a 2 in front of here, which means I now have 4 Ags, and now I'm balanced. Okay? If you didn't see that and you put a 2 in front of here and then had to scratch it out, guys, that's totally fine. All right? For number 8, if you notice, I take one item and it's going to be broken apart into 2 separate things. No, don't put 2 different things here. Okay? This is just one item. So if you look at here, this is obviously going to be decomposition. Let's identify what type of decomposition. All right? I have a metal chloride as one of my products and O2. So if you look at your cheat sheet, if you notice, it's going to be a 2E, meaning you have a metal and ClO3 is going to be your reactant. So it's decomposition, we knew that. But it's going to be your metal and ClO3. Well, my metal is Sr, which has a 2+ charge, and ClO3. Now, from all of the practice we've been doing, no, originally I did not tell you the charge of ClO3, but on the quiz I gave you a problem where you could have determined it. The charge of ClO3 is -1, guys. So I need to cross my charges, okay? So I end up with Sr in parentheses ClO3, close my parentheses 2, because ClO3 is a polyatomic ion that I did not teach you, but you still need to be able to do that, okay? Not too bad once you know the charge of that. Now, I have 1 Sr, 1 Sr, 2 Cls, 2 Cls, 6 O, so I need to put a 3 in front, okay? Notice if you didn't know the charge here, if you go back up here, you could have determined the charge of ClO3 by uncrossing your charges, all right? Ba is 2+, ClO3 would be 1-. Okay, let's look at the next problem. I've got MgClO2, it's breaking apart into 2 separate things. Obviously, it's going to be decomposition again. Okay, now let's talk about what my products are going to be. It's going to be Mg as one of the products, okay, and Cl is the other product because it's just simply breaking apart. It's a 2A decomposition, simple breaking apart, but Cl can't be by itself, so it needs to be Cl2. Right? And if you notice, that beautifully balanced me. I did not put the 2 there because it would balance me. I put it there because Cl is diatomic. Okay? Let's go on to the next one. 10. CaO plus H2O gives me just one product. If you notice, this is going to be synthesis because I'm taking 2 separate things, adding them together to create one product. It's going to be synthesis. Alrighty, let's work on this. If you go on your cheat sheet, what you'll notice is this is a metal oxide plus water. What you'll get is a base. No, you can't just write base here. But what you should remember is that a base is just your metal and OH after it. Remember, the charge of OH is -1. Okay, so my metal here is Ca with a 2+ charge. Okay, and OH has a -1 charge. So when I cross my charges, I end up with Ca. Uh-oh. Sorry, guys. Slight technical difficulties. Let's see if this will make it better. So it would be CaOH2, right? Here we go. There we go. Okay, remember the parentheses because OH is a polyatomic ion. And there we go, I'm done. Okay, next one, HBr plus MgOH2. What you should notice is that I have 2 different compounds combining together. This is going to be double replacement. Remember, for double replacement, guys, innies and outies, H and OH are combining together, Mg and and Br are combining together. Okay, it's going to be H and OH combining together, not H and OH2. So when H, which has a +1 charge, and OH, which has a -1 charge, combine together and cross your charges, you get HOH. Remember, HOH is just H2O. No, on the test, I did not give you full credit for HOH. It's not HOH, it's H2O. Okay? Mg and Br, Mg has a 2+ charge, Br has a -1 charge. Cross your charges, you get, for your second product, Mg, Br, 2. Notice here, guys, we're not doing any net ionic reactions. All right, that's not what I'm asking for. I'm just asking for simple double replacement reaction. Okay,